So, let me focus this, but this is going to be the section on parabolas here. So, parabolas are actually one of several excuse me, graphs that are called conic sections. Alright, so these conic sections were discovered by Rene Descartes in the 17th century, so you can see that here. And the different types of ways that he categorized these conic sections are you could see here a pair of lines, a point, a circle, a parabola, an ellipse, a hyperbola, or just having no graph at all. So the first one here, you can see that it's a circle here, and I don't know how well you can see the outline, but there's the circle. So it's a plane intersecting two cones like this, and then if you tilt the plane a little bit, you get an ellipse, and then if you tilt the plane this way, you get a parabola, and this way you get a hyperbola. Alright, so of course you could have a parabola if you had the plane in the upper half of the two cones as well. But one thing that you should sort of keep in mind of how are we going to determine which of these conic sections is which is there's something called eccentricity. So that's Eccentricity, eccentricity. And we usually just denote that by the letter E. But circles have an eccentricity of 0, and ellipses and these are just what I've been using these words already, but these are what just people would call an oval usually. All right, so it's something where it's like it's round in nature, but not a circle. All right, and that's when the eccentricity is between 0 and 1. And then for a parabola, the eccentricity is equal to 1. And then for a hyperbola, the eccentricity is bigger than 1. So now we'll get into how to calculate the eccentricity here in a moment, but let me talk about the geometric definition of the parabola first, since that will be the first conic section that we will talk about. Although we already did talk about circles earlier, but we have talked about parabolas earlier, but we haven't talked about them from a geometric standpoint. So before, all we talked about was the standard form of the equation for a parabola, which is y is equal to a times x minus h squared plus k. Alright, but now we're going to be looking at this from a different standpoint, and another way to describe a parabola is the set of all points in the plane that are equidistant from a fixed point f, called the focus, and a fixed line L, called the directrix. Now, the thing that I think that if you look at this diagram here shows is that here's the focus, and the focus is fixed. All right, a fixed point F, and the line L. So the line L, the directrix, is also fixed. So this is a fixed line here. All right, and then the other thing that you should notice is that these these actually, and then when they say axis here, this means axis of symmetry. All right, so it's not actually just axis, like it's axis of symmetry, but you can just write axis, and I would know what you mean, and most people would know what you mean. But the V is the vertex, so that's the HK that we've always talked about in the past. And so the axis of symmetry and the directrix are actually perpendicular. So these are right angles here. So these are perpendicular. So the axis of symmetry and the directrix are perpendicular. All right, so that's what that means. And then the other thing is that um this is actually the vertex is the halfway point between the focus and the directrix. So this distance right here from F to V and from V to L are actually equal. All right, so F to V and V to the line L are actually equal. So the V is the halfway point here, or the midpoint. So these, so V is the halfway point, and I actually don't know how you really want to write this, but it's the midpoint. All right, so the other thing that you should notice is that the focus is actually inside of the parabola, so to speak. All right, so it's in the direction that the parabola opens, whether that's up or down, and the directrix is always outside of the direction of where the parabola is opening up or down. All right, so keep that in mind as well. So now, again, if you have any questions, please feel free to ask. But right now, I just want to talk to you about this page right here. And so remember, the the equations for a parabola that we've dealt with before have been of the form y equals a times x minus h squared plus k. And so right now, if we are actually if we're actually going to look at this in the way that it is, and you see here, this box here is only for parabolas with a vertex at 0, 0. So that's HK. Okay, so then if I actually look at this and I have y is equal to a times x minus 0 squared plus 0, then I have y is equal to a times x squared. Now, the one thing that you should automatically notice is that this equation is written in the form x squared equal 4py. So then what I should do actually is then divide by a. So 1 over a y is equal to x squared. So this actually is the same thing. So whenever you see 4p, that's actually equal to 1 over a. All right, so this is just a different way to write this so that you can figure out what the focus is, because the focus is going to be 0p, and the directrix will be y equals negative p, and then the parabola will open upward if p is greater than 0, and downward if p is less than 0. All right, so now the other thing that you could notice is that if you took this one here, all right, and you had x squared is 4py, and you solve that for y, then you would have 1 over 4p x squared is equal to y. So you could think of it like that as well, if you want to think of it as y equals instead of x squared equals. So remember that these parabolas with a vertical axis of symmetry are functions, because these all pass the vertical line test. So these are functions. If the parabola open left or open right like this, then they would not be functions because they would not pass the vertical line test. So try to remember that as well. So just to make sure that we're all clear on this, then this F is the focus. All right, and then here is the axis of symmetry. So the axis of symmetry is always written as x equals, and that would be x is equal to h. All right, and then here's the vertex. So the vertex is hk, or in this case 0, 0. And then here's the directrix down here. So this is the directrix, and the directrix is always y equals negative p. And so this is one where p is positive. It's up here at 0p. And so that means that because p was positive, this one opens upward. And then the same thing for parabolas that open downward. You see the axis of symmetry right here. So there you go, axis of symmetry. And then you have the directrix, and then you have the focus, and then this has a vertex at HK, and then you notice though that this one opens downward. All right, so also though, you can notice that what I said earlier is true, that the focus is always in the direction that the parabola is opening. So this one opened up, so the focus was up here. This one opened down, so the focus was down here. All right, so let's try an example here. Find the equation of the parabola described and then sketch its graph. So the focus is at 0, negative 1, so that would be 0 and p. And the directrix is y equals 1, so that's y equals negative p. So I know that p is going to be negative 1. All right, so the equation is x squared is 4yp, or 4py. So then p was negative 1. So x squared is negative 4y, or if I divide by a negative 4, negative 1/4 x squared is equal to y. So there you go. That's how I would figure out the equation, and now I can find out what the graph looks like. So here's the graph. All right, so I know that the vertex is at 0, 0. So the vertex is at 0, 0, and the focus was at 0, -1. So here's the focus, and the directrix was y equals 1. So what I know is that the directrix and the focus are, well, let's look at the graph again, just so that you're clear on this. See, the focus and to the graph and the graph to the directrix are the same distance. So again, what I'm saying is that this distance right here is equal to this distance right here. So all I need to do then is look at this graph and say, well, all right, then here is the directrix, here is the focus. So if I go 1 unit away from the focus, and then, well, actually, probably, what do you want to do? You probably have to go 2 units away for it to make, well, yeah, 2 units away from the focus, and then 2 units up. Then I can tell that there has to be a point right here. All right, and because it's symmetric, then I can draw another point 2 units away and 2 units away and right there. And then if I want to have any other points after that, then it would definitely be some that would go out at an angle like this and be harder to find, but you could find them. All right, but right now I could tell that the graph just opens like this. All right, so this point is at 2, -1, and this point is at -2, -1. So again, you could actually figure that out by substituting points in here, but if I can tell you that this distance right here is equal to 2, and this distance right here is equal to 2, then I can draw the graph without actually substituting points into the equation. So this is just a way to graph the parabola with maybe a little extra less, like a little less work. Maybe not. Like if you're not a visual person, then of course this might actually seem like it's more work for you. All right, let's try another one here. All right. Oh, let's see where. Oh, okay, there we go. So now we have what page is this? 304. All right, so we have the vertex at 0, 0, so that's HK. And the axis of symmetry is the y-axis. So the y-axis is going to be x equals 0. And remember, this is always, the axis of symmetry is at x equals h, and contains the point 5, 3. So they tell us an x and a y value this time. All right, so here we go. Here is 0, 0, and here is 1, 2, 3, 4, 5, 1, 2, 3. So here 5, 3. But I know this is symmetric, so I have a point at 1, 2, 3, 4, 5, -5, 3. And so the parabola looks like this. Now, again, I knew this was symmetric, so this distance is 5, and then this distance over here was 5, and then what else did they tell us? They told us the vertex was 0, 0, and then they told us the axis of symmetry was x equals 0. Alright, so axis of symmetry x equals 0. So now all we need to do is actually find the equation now. So the equation is going to be, alright, so it's x squared is 4py. So x was 5 and y was 3, and p is unknown. Alright, so then 5 squared is 25, so 25 equals 4p times 3 is 12p. Then I divide by 12, so p is 25 over 12. So then to find the equation, I just substitute the p equals 25 over 12 into x squared is 4py. So then that will be x squared is 4 times 25 over 12y, and then 24 over 12 is 1/3, so x squared is 25 over 3y. So that is the equation. Y is equal to 3 over 25 x squared, or x squared is equal to 25 over 3y. So you could write it as, y is 3 over 25 x squared if you wanted to also. And so look at this one. I didn't actually need to know the focus or the directrix to do this problem here, but I could find it because I know P was 25 over 12, so that's a little bit above 2, so the focus is actually right here. So the focus is at 0, 25 over 12, and then the directrix is down here. So the directrix here is at y equals negative 25 over 12. Alright, so now let's go ahead and try another one here. So the vertex is at the origin, so HK is 0, 0, and the focus is at 0, negative 1/4. So that's 0 and P. So that means P is negative 1/4. So let's actually go ahead and look at this now. Since P is negative, P is less than 0, so that means that the parabola opens downward. Alright, so now here's the vertex 0, 0. The parabola opens downward, so here is a 0, negative 1/4 right here. Oh, yeah, 0, negative 1/4. So F 0, negative 1/4. And then here is the vertex at 0, 0. And hopefully you can see that this one is actually going to open a very, not very narrow actually, but narrower than this one, of course, but it's actually just, believe it or not, well, this is actually, this will look like a scam almost the way that I'm drawing this, but believe it or not, though, once we figure out what the equation is, it will be one that we've worked with a lot of times. The equation is going to be x squared is 4py, but p was a negative 1/4, so x squared is 4 times a negative 1/4 y, so x squared is 4 times a negative fourth is negative 1, so negative y, or just y is negative x squared when you multiply by the negative 1. So this is just y equals negative x squared. All right, so again, if you have any questions, feel free to ask, but these are just some different ways that you could sketch the graph given only partial information about it. So given the parabola with the equation x squared is negative 4y, let's find the axis of symmetry. So axis of symmetry, and then the focus, and then the directrix. All right, so we'll find all of these items for this particular graph here. Okay, so here we go. So I know that the axis of symmetry is always at x equals h. The focus is at 0p, and the directrix is at y equals, all right, y is equal to p, or actually negative p, yes, y is equal to negative p. All right, so now that means that you really need to figure out what p is. And so remember that I said originally that the uh, well, the 4p was equal to 1 over a, right? So in other words, since this is x squared is 4py, that means that the negative 4 has to be equal to 4p in this case. And then if you divide by 4, negative 1 is p. So then, here we go then. So we know that the vertex is still at 0, 0 because we haven't dealt with any that have been shifted yet. So that's the good news for us, is that we haven't dealt with any shifting yet. So the vertex is at hk is 0, 0. So we know that axis of symmetry is x equals 0. The focus is 0p, which is 0, negative 1. And the directrix is y equals negative p. So that would be y is equal to the opposite of p, which is 1. So then we can draw the sketch of the graph. There is a point at the vertex 0, 0, the focus is at 0, negative 1, and the directrix is at y equals 1. And so then if I go one unit over from the, well, believe it or not though, think about this though. This is actually the same. This is actually the same as example 1a, right? But it's actually written differently, because if we multiply by negative 4 here, then we have x squared as negative 4y, right? So we actually found the different, the graph, but in a different way here. So just like that example, I can go over 2 and up 2 and then draw the point, and then over 2 and up 2 draw the point, or use symmetry, and there we go. So just keep that in mind, that they actually, in the last one here, just gave us the focus and the directrix, and here they gave us the equation that had that focus and directrix. All right, so hopefully you enjoyed that here. So now let's try another one here. Again, if you have any questions, please feel free to ask. So find an equation of the parabola whose graph is given. So the focus is at 0, negative 3, and that's 0p. So p is negative 3, and we know that p needs to be negative since this opened downward. So then the equation is x squared is 4py. So p was negative 3. So it's x squared is 4 times negative 3y, or x squared is negative 12y. Or you could write it as negative 1/12 x squared is equal to y. So either way is acceptable. All right, so hopefully that makes sense, that that one was actually not supposed to be too difficult here. So now here's another one. So we have the focus and we have the point right here. So the thing is that we actually don't know how how right how far up the y-axis of focus is. We just know that the focus is at 0p and that this point is at 5p, and then the vertex is 0, 0. So we need to figure out what p is. So the equation is still x squared is 4py. So we can substitute the point 5p. So let's substitute the xy equals 5p. So that means x is 5 and y is p. So I have 5 squared is 4p times p. So 5 squared is 4p squared. And then square the 5. So 25 is 4p squared. Divide by 4. So 25 over 4 is p squared. And then take the square root. So now remember, here we see that this opens upward. So that means that p has to be positive. So when I take the square root, I need the not the negative number, I need the positive number. So take the square root. So 5 over 2 is equal to p. So then I just substitute that back in here. So the equation is x squared is 4 times 5 over 2y, or x squared is 4 over 2 is 2, and 2 times 5 is 10, so 10y, or you could write it as 1/10 x squared is equal to y. Either way is fine with me if you want to solve for the y instead. All right, so these two were not necessarily the most difficult problems, but they did require a little bit of extra manipulation of the equation. And so this one here, let's try this one. This might really throw you off if you haven't actually seen these at all. So here's the focus, and all we know again is that this is at 0p, and the vertex is at 0, 0, and this has a slope of a half. So I know then that I can see that I don't know the equation of the line here, but I do know that one of the points on the line is actually right. One of the points on the line is 0p, and the other one is this point. So how am I going to find that? Give me that other point. Well, all right. This is 2. And then some missing y value, right? So what I know is that the slope of a line is m is y2 minus y1 over x2 minus x1. And the slope was a half. And then I can label these, and like x1, y1, x2, y2. So then I can label this so that it is, all right, it will be y minus p over 2 minus 0. So then again, that was equal to a half. So then y minus p over 2 is equal to 1 over 2. And then I see that the denominators are both 2, so I just need to set the numerators equal. So y minus p is equal to 1. And then I add p, so y is equal to p plus 1. So this point here is 2p plus 1. Now, what I do is the same thing that I did in the last problem. I know that the equation is going to be x squared is 4py, and then I substitute the point there. Xy is 2p plus 1. So we have 2 squared is 4p times p plus 1. And then I will go ahead and distribute here. So 2 squared is 4. So I have 4 is equal to 4p squared plus 4p. Then I'll subtract the 4 to get 0 is 4p squared plus 4p minus 4. Then I can divide by 4 on each side to get 0 is p squared plus p minus 1. And then hopefully you can see that this will be one where you'll want to go ahead and use the quadratic formula to solve. So A is 1, B is 1, C is negative 1. So P will be negative B plus or minus the square root of B squared minus 4AC all over 2A. So then we have a negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 1 all over 2 times 1. So that gives me negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 1 is 5 all over 2. So that is P. So then all you do now is substitute that into the equation. So then the equation will be x squared is 4py. So that gets substituted in here. So how do you know if you use the negative one or the positive answer? Well, this is actually this is opening upward, so p is greater than 0, so it needs to open upward. So that means I need to use the positive answer. So that will be x squared equal 4 times negative 1 plus the square root of 5 over 2y. And then 4 over 2 is 2. So I have x squared is 2 times negative 1 plus the square root of 5y. And there you go. That is the equation of that parabola. All right, so again, if you have any questions, please let me know. Okay, so then that's all I have to say about vertical parabolas. But here is a little bit of information about the horizontal parabolas. So then remember then that these horizontal parabolas, or parabolas with a horizontal axis, these are not functions. So these are not functions. So here you see what you really need to remember for the horizontal parabolas. Y squared is 4px. Here's the vertex, the focus, the directrix, and how to tell whether the parabola opens to the right and if it opens to the left. So that's really all of the information that you need to know here. And then you can see examples here of this happening. Here's p is greater than 0, so it's opening to the right, and here is p is less than 0, so it's opening to the left. All right, so now this marker I don't like here, but I don't actually know where all the other ones went to. This is actually very, very bizarre because they were all here last week. Oh, here they are. All right, so now let's go ahead and try a couple of these examples that have a horizontal parabola or a parabola with a horizontal axis of symmetry. So find the equation of the parabola described and then sketch its graph. So the focus is at 7, 0, and the vertex is at 0, 0. So the focus is at P0, so this will be P0, and the vertex is at HK. So I know that P is equal to 7, and since that's greater than 0, P is greater than 0, so this is opening to the right. All right, so here we go. The focus is at 1, 2, 3, 4, 5, 6, 7, and then the vertex is at 0, 0. So then what are you going to be able to do about this here? Well, I know that the equation is going to be y squared is 4px. So then y squared is 4 times 7 times x. Once I substitute in the p equals 7, so y squared is 28x. So then all I need to do is go ahead and then figure out what some points are on this graph. Well, all right, if I substitute in a x is equal to 0, of course I get 0. But if I pick 7, I get then, by the way, this is actually very, very interesting here, but if you get y squared is equal to 28 times 7, right? And so 28 times 7 happens to be 196. So y is equal to the square root of 196 plus or minus that. So then that means y is equal to plus or minus 14. So it just so happened that this worked out for us, that this was a perfect square here, the square root of 196. So here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 7, 14, and again, this is symmetric, so we didn't even need to know this was plus or minus. We would have just been able to go down here and figure it out. It was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. And here's a point at 7, negative 14. And the parabola looks like this. All right, so hopefully you enjoyed that. But this one, you can tell, opens fairly widely here. All right, so let's try another one here. We have what do we have here? We have the directrix. So the directrix is at x equals negative p, and the vertex is at hk. So that if negative p is negative 1/7, then that means p is 1/7, which means p is greater than 0, and this opens to the right. All right, so we have the directrix is at negative 1/7, so that will be over here. And then the vertex is at 0, 0, and the focus is at a positive 1/7. So there's the focus at 1/7, 0, and this was the directrix at x is equal to negative 1/7. And so now we just really need to figure out what the equation is so that we know how widely this opens here. So the equation is going to be y squared is 4px, so y squared is 4 times the 1/7 x, so y squared is 4/7 x. So then what I might want to do is let x be equal to, well, again, 0, 0 is a point, but if x is equal to 7, then we have y squared is 4/7 times 7. So y squared is equal to 4. And then if I take the square root, y is equal to plus or minus the square root of 4, but that's a perfect square of 2. So we have a point at 7 and 7 and 2 and 7 and negative 2. So, oh boy. So that's 1, 2, 3, 4, 5, 6, 7, and 2, and 7, and negative 2. And then this parabola just opens like this. And like this. So this is going to be 7, 2, and this is going to be 7, negative 2. Excuse me. So I hope that you enjoyed this. So here is another example. So given the parabola with the equation y squared is equal to negative 16x, find the axis of symmetry, focus, and the directrix. So they want the axis of symmetry, and they want the focus, and they want the directrix. All right, so remember that the axis of symmetry is going to actually be equal to, all right, y is equal to k, or um, well, yeah, so y is equal to k, and then the focus will be at p0, or yeah, p0, and the directrix will be at x is equal to negative p. So this is actually at y is equal to 0. All right, so that one was not actually difficult for us to find, right? But now, what do we need to do here? Um, well, we need to find the focus. So we know y squared is negative 16x, but the equation is y squared is 4px. So just like before, when we didn't know what p is, we can equate these to get negative 16 is equal to 4p, then divide by 4 on each side, so negative 4 is equal to p. So this means because p is less than 0, or it's negative, this is going to open to the left. All right, so this opens left. So we have negative 4, 0, and the directrix is at x equals then the opposite of that, so a positive 4. So here we go. Here is the sketch of the graph. We know we have a focus at negative 4, 0, and the directrix at x equals 4, and the axis of symmetry is right here in the middle. And so all you really need is to pick some points here on the on the graph. So what would that look like? Well, all right, if I pick 0 for x, I get 0. And I will just fill this in for you here. If you pick 1, you get, if you pick 1, you get a 4. and a actually you get a -4 in this, so an imaginary number. So -1 you get a 4 and a -4. So remember, this is not going to be a function. So you have -1 4 and -1 -4. And so the graph looks like this. All right, so this is going to be -1 4 and -1 -4. So again, I just did that by substituting the points into this equation here and then figuring out what the y values would be. There you go. So now, again, if you have any questions, please feel free to ask. But here is another example here. So as we go, these might feel like they're getting a little bit trickier. I hope that they don't end up being something that seem too unreasonable, but I do want you to see different types of examples that you might encounter. So find an equation of the parabola whose graph is given. So we see that there is a directrix at x equals -p. So that means that p is equal to 2. And the vertex is at 0, 0. So the equation is y squared is 4px. So this is just going to be y squared is 4 times 2x, or y squared is 8x. That's it. So it looks like it's a little bit more difficult, but we just had to figure out what p is. All right, so now let's try another example here. So this square has an area of 16. So that means that if the area is 16, each side of the square has a length of 4, because the area of the square is like side squared is equal to the area, so 16, and then I take the square root, so s is equal to the square root of 16, or 4, so that I know that each side of the square has a length equal to 4. So then if the directrix is right here at x is equal to -p, and I can tell that's a distance of 4, so x is equal to -4, that means p is just equal to 4. So p is equal to 4 here. So since p is equal to 4, then we know that y squared is 4px, or y squared is 4 times 4x, or y squared is 16x, and that is the equation of the parabola. All right. The other thing then that I have not talked about is the focal diameter, and that's the segment that runs through the focus perpendicular to the axis with the endpoints on the parabola, and that's the latus rectum, and its length is the focal diameter of the parabola. So what that is saying, it's running through the focus perpendicular to the axis. All right, so here is the axis of symmetry, and then here is the latus rectum right here, and its endpoints are on the parabola, so you can see its endpoints on the parabola, and then it is perpendicular right here. So that's what it is. All right, this segment right here, and the length of it is the focal diameter. So again, the length is the focal diameter. So that would be 2p plus 2p is 4p. So this distance right down here, see how this one was 2p? So this one will be 2p also. So then that will be 4p. So really, if you think about it, that 4p shouldn't seem unfamiliar because that's where the 4p comes from in the equation 4px. All right, so keep that in mind as well. All right, so now let's look at the next one, and this will be our last page. So find the focal diameter of y equals 2x squared. So remember that the equation is going to be x squared is 4py. So then if I write this in that format, it is going to be, all right, now remember how this actually looks here, right? I need to solve this for x squared. So divide by 2. So 1/2 y is equal to x squared. And then I know that the focal diameter is 4p. So 4p is 1/2. So therefore, the focal diameter is 1/2. So hopefully that did not seem too difficult there. All right, so here's the application problem. Suppose that the diameter of a parabolic mirror is 10 inches and assume that the mirror is 5 inches deep at the center. So here is the graph here. So the diameter is 10 inches and it's 5 inches deep at the center. So here we go. So we have, here we go. Sketch a parabolic cross section of the mirror in a Cartesian plane so that vertex is at the origin and it opens to the right, and the x-axis is the axis of symmetry. So they want the x-axis here to be the axis of symmetry. So if I want this mirror to be 5 inches deep at the center, I want it to be 1, 2, 3, 4, 5. And then if the diameter is 10, that means at that point then I need to have 1, 2, 3, 4, 5 units above the axis of symmetry and 1, 2, 3, 4, 5 units below the axis of symmetry, so that the diameter here is equal to 10. 5 plus 5 equals 10. So this point happens to be at 5, 5, and this point happens to be at 5, -5. And now the thing is that we want the standard equation of the parabola. So this is a parabola that opens to the right. So it's a horizontal parabola and it opens to the right. So I know that we have y squared is 4px because that's the format for the parabolas with a horizontal axis of symmetry. And then similarly to what we did before, we can use the point here, 5, 5, to find p. So 5 squared is 4 times 5x, so 25 is equal to 20x. Then divide by 20, so 25, oh, actually 20, that should be p, not x. I had the wrong letter, but all right, 20p. So then 25 over 20 is equal to p. So then if you reduce that, then 5 over 4 is equal to p. So then you just substitute the p is 5 over 4. So y squared is 4 times 5 over 4x. The 4's divide out, so y squared is equal to 5x. So that is the equation here. And then if they want to know how far is the focus from the center of the mirror, then the center of the mirror was right here. So here's the vertex, right, 0, 0. But the center of the mirror was at the 5, 0, and the focus is at P0 or 5/4 0. So 5/4 0 is right here. So this is the focus at 5/4 0. So the distance the focus is from the center actually is this distance right here. So then remember, since the focus was at 5/4 0 and the center is at 5, 0, that the distance is just going to be 5 minus 5/4, or 3 3/4 units, or 3.75 inches, because the units were inches, right? Inches away. So that's it. Like I think that the most difficult part for me about this particular problem is just making sure that I know what they mean by the diameter of the mirror, by the center of the mirror, making sure I have it opening the correct direction, and then just going from there, not making a mistake like here, accidentally writing down the wrong letter or dividing out something wrong maybe. But other than that, I don't think it's too difficult, but setting it up and visualizing it is probably the trickiest part. So that is it for this section here.